In today's lecture, we are going to discuss in more detail ionic compounds. As a review, I would like to go over how to determine whether or not compounds will form bonds ionically, covalently, or metallically. Please check your answers for the bonding worksheet on Canvas. NO2, a nitrogen and oxygen. Both of those are nonmetals, so remember you have to ask yourself, are they metals, nonmetals, or metals? Just plain old metals. Those are both nonmetals, so that will be a covalent compound. Hg is just a metal by itself, so that's metallic. KCl, K is a metal, Cl is a nonmetal, and so that will be an ionic compound. FeBr3, Fe is a metal and Br3 is a nonmetal, so that would be ionic. And CO2, carbon and oxygen, carbon is nonmetal, oxygen's a nonmetal, so that would form a covalent bond. Ionic bonding occurs between cations and anions, as we've already discussed. They're held together by opposite charges, positive, negative attraction. Ionic compounds are also called salts. The simplest ratio, sorry about the spelling there, of elements is called the formula unit. And bonds are held together through the transfer of electrons in ionic compounds. Electrons are transferred so that the most stable configuration is achieved, so one that looks like a noble gas, and that will ensure that there's a full outer shell, or the octet rule is followed. So you can ignore the box at the bottom for right now. When writing ionic compounds and ions, the ions that we're going to be considering are one of two types. They're either monoatomic ions, and if you break down that word, mono means one atomic atom. So those are like calcium +2, or sodium +1, or potassium +1, or aluminum +3, or chlorine -1. There's another group of ions called polyatomic, and those are chemical compounds that stick together, and as a group they have a charge. And you will need to know the list of polyatomic ions below. If we look at the breakdown of the root words, poly means many and atomic is atoms. So the first one is ammonium, and that has 1 nitrogen, 4 hydrogens, and it has a +1 charge. -1 charge is hydroxide, that's an OH -1. Nitrate is NO3 -1. The -2 charge polyatomic ions are carbonate, which is CO3 with a -2 charge, and SO4 with a -2 charge is sulfate. And the polyatomic with a -3 charge is phosphate, and phosphate is PO4. One way you can remember these is just kind of a little, not a jingle, but just a way to remember it. O is a hydroxide, No is nitrate, Co is carbonate, So is sulfate, and Po is phosphate. Oh no, Co, So, Po. And I would probably make note cards with each of these, the names on one side and the formulas on the other side. Whenever you write more than one of these polyatomics, you will be using parentheses, because the NO3, for example, the 1 nitrogen and 3 oxygen will always stay together. So remember, with ionic bonding, you have one atom that will lose an electron and another atom will gain an electron. So for example, sodium has 1 valence electron, Chlorine has 7, so it will give 1 electron to chlorine. The metal, sodium, tends to lose the electron, and the nonmetal, in this case chlorine, tends to gain. And both of them do that so that they have a full valence electron. When you're writing the Lewis dot structure, which is the electron dot diagrams of both of them, the chlorine will be surrounded by 8 and sodium will not be surrounded by any. So what if I took calcium and phosphorus and formed an ionic bond? You know it will form an ionic bond because it's between a metal and a nonmetal. What would that look like? So if you have calcium and phosphorus, you look at the periodic table. Calcium is an alkaline earth metal, so it's going to have a positive 2 charge. And phosphorus is over in the nitrogen group. And so it has 1, 2, 3, 4, 5 valence electrons, and it wants 8, so it's going to have a negative 3 charge. So you can just put a positive 2 here and a negative 3 here. Those are the oxidation numbers. So if you just write the electron dot for each of these, you would find that calcium has 2 valence electrons. Phosphorus has 5, so 1, 2, 3, 4, 5. So 1 calcium could donate 2 electrons to a phosphorus, but we still would have 1 extra space in phosphorus's outer shell, so it would still not be happy. So if we took another calcium, that calcium could donate the 8th valence for phosphorus. And then if we took another phosphorus, 1, 2, 3, 4, 5, then this electron could be donated to that phosphorus, and then we would still need 2 more valence electrons for that phosphorus. So if we had a third calcium with 2 valence, then that could donate 2 phosphorus, or 2 electrons to that phosphorus. And so this formula would have 3 calciums and 2 phosphoruses, and so it would look like calcium 3, phosphorus 2. So how do I write the molecular formulas given the ions? And remember, they're called formula units. So you will write down a shortcut way of doing that instead of doing what we just did by putting the electron dot diagrams together to figure it out. You will first write the metal, or the cation, and then you will write the charges on top of that compound. You will cross the charges to form the compound. So let's practice this. So I would press pause and copy down this chart, and then when you're ready I will show you how to create these ionic compounds. So the first thing you want to do is you want to write the charges on top of the atom. So if you have calcium, calcium has a +2 charge, and you know that from looking at the periodic table. It is an alkaline metal. It has 2 valence. It's going to give those 2 valence away. Fluorine has a -1 charge, and you know that because it is a halogen. It has 7 valence electrons, and it wants 8, so it's going to gain 1 negative. And it may behoove you to get out this periodic table from the other day where we have the oxidation numbers, and these are the charges when they make ions at the top here. So alkali metals are +1, alkaline earth metals are +2, the boron group is +3, -3 is the nitrogen group, -2 is the chalcogens or the oxygen group, and -1 is the halogens. And remember, noble gases have a full outer or valence shell, so they're not going to have any charges. They're not going to gain or lose. So going back to this, calcium has a +2 charge, and fluorine has a -1 charge. And what I'm going to do is I'm just going to cross the numbers themselves. Okay, so I'm going to put, there's going to be 1 calcium to 2 fluorine. And that makes sense because the entire compound has to be neutral. So if you have 1 calcium with a +2 charge and you have 2 fluorine with a -1 each, then -1 plus -1 is -2, and then +2. So the whole thing is going to be a neutral compound. 2 minus 2. You don't have to write the 1. So what I want to do now is show you that the number of atoms for each element when writing the compound. So the calcium, there's only going to be 1 atom of calcium. And the fluorine is going to be 2 atoms of fluorine. So whatever, this is called the subscript, and whatever this subscript is, that tells you how many of each element that you have. And you probably knew that coming into this lecture. So lithium and chlorine. Lithium has a +1 charge, okay, and you know that because it is an alkali metal, and alkali metals have 1 valence, and so they're going to form +1 charges. Chlorine has a -1 charge, so you're going to cross just the numbers, and it'll be LiCl. And so for the lithium, there's 1, and for the chlorine, there's 1. Sulfur and strontium. Now remember, I said you need to write the cation first, and the cation is what is formed by the metal. So strontium, it is an alkaline earth metal, so it is going to have a +2 charge. And sulfur is going to have a -2 charge. And so you could cross the charges to where it's Sr to S, but you don't need to keep it like that. You want to reduce it to the lowest term, so it's going to be SRS. So for every strontium, there is 1 sulfur. So ammonium. Ammonium is NH4. That was that Onokoso-Po and Nathaniel Hawthorne IV. That's how you can remember ammonia. It's a Nathaniel Hawthorne IV. And it has a +1 charge. Nitrogen is in a group that is right here. It has a -3 charge. So this polyatomic ion acts like a metal by giving away 1 valence between all of those molecule or elements. And then so if you cross this, you're going to need 3 +1s for every 1 -3s. Okay, so it's going to look like this. Because Nathaniel Hawthorne IV or ammonium needs to stay together, and you write that first, you need to use parentheses. And so there are 3 of those, and then nitrogen, there's 1 of those, and we're not going to write that. So let's talk about how many nitrogens are there in this entire compound. Well, you're going to multiply. It's kind of like the FOIL, or the distributive property. You're going to use that like from math. So 3, there's going to be 3 times, this has an implied 1. So 3 times 1 is 3 nitrogens plus this one. So the whole compound has 4 nitrogens. and then there's going to be 3